Okay, so today we're going to look at finding the area of a segment. I don't really understand, and I think it's kind of crazy that it's called the area of a segment because that's this orange area here. And it's the area between the triangle that was formed by the radii and the edges of the circle, right? It can be kind of difficult, but I'm going to try to make it as easy as possible. To find the area of the segment, what you got to do is you got to find the area of the sector, okay, which is just a formula. So you're going to find the area of the sector, and then you're going to subtract that from the area of the triangle. The area of the triangle is the difficult part. So the area of the sector is not too bad. So let's go ahead and do that real quick. So to find the area of a sector, you have the formula, which is m over 360 times pi r squared, right? Now, if you look, the area of the sector that I'm actually trying to find is this blue sector here. So I want to find the area of this whole thing. And if I find the area of the whole thing and subtract off the triangle, then I'll be left with that orange part, which makes sense. Okay, so here's what we're going to do. So to find the area of the actual sector, I'm going to do 135 over 360, because that's my measurement of my angle, times pi times 10 squared. Now what I'm going to do is I'm just going to go ahead and leave pi in my answer. And so what I'm going to do is I'm just going to kind of just multiply the numbers and just leave pi in my answer, because that's going to make it more exact. So 10 squared is 100, right? I'm going to take that times 135, and then I'm going to divide that by 360. And that's 37.5. So 37.5 pi. That's my area of my sector. Now we're going to leave that here, and we're going to go find our area of our triangle. Okay, so I'm going to do that down here in the bottom corner. Now this triangle is isosceles. That's what we need to remember. It's isosceles because we know the other side is 10. We don't necessarily know if this is 10, which we can tell right now that it's not, and that's because of that 135 degree angle. There's no way that it could be 10. So what I'm going to do is I'm just going to draw a triangle for you, okay, that looks very similar to the triangle that we were given. So I'm just going to go ahead and try to draw that as best I can. Now I'm pulling it out so that it looks isosceles, and then the vertex angle is near the top, which is my central angle, which is 135. Right? We also know 10 is here, and we know 10 is here. So in order to find the area of a triangle, we have to do 1/2 base times height. Well, we have none of that. We don't have the base or the height. Because, see, the base and the height have to be formed by a right angle, and we don't have that. And so what you're going to have to do, every time that you try to find the area of a segment, you have to split this triangle down the center, forming a right triangle. Okay? That will allow us to find this part right here, which is our height, and it will allow us to find our base, which is the bottom down here. Now, when I split this isosceles triangle, that splits that 135 into half. And so that's going to actually be 67.5. So this triangle has a 67.5 angle here, and it has a 67.5 angle on the other side, right? So let me draw that a little bit bigger for you so you can kind of see what's going on. This time I'm just going to pull out the right triangle. So we're going to just look at this part right here, because that's the only part I really am concerned with. Okay, so now I know that this is 67.5, and this is 10. Now I need to find this part right here, because if I don't find that part, then I won't have my height. So to do that, I actually see that this is a right triangle, and so I can actually use trig. I can use SOHCAHTOA. Using 67.5, I'll know that this is the adjacent angle, or the adjacent side, I'm sorry, and that this is the hypotenuse, right? And so that means I can use the SOHCAHTOA, which is cosine. We're going to use cosine, because that's the one with A and H in it. So cosine of 67.5 is going to be equal to the adjacent, which is A, or X, over 10. And then we're going to cross multiply. So we'll have 10 cosine of 67.5 equals X. So 10 cosine of 67.5, making sure that your calculator is in degree mode, is 3.83. So that's what my height is. And basically that would go right here, right? So that's 3.83. Now I need to find my base, right? I need to find my base, which this over here would be half of my base, okay? And so what I want to do is I can do one of two things. I can use the Pythagorean theorem, which is what I'm just going to go ahead and do, or we can use trig. If I use the Pythagorean theorem, this would be b, right? So we could do a squared plus b squared equals c squared. So I'm just going to scroll down a second. So a squared plus b squared equals c squared. 3.83 squared, sorry about my 3 there, plus b squared, because we don't know it, equals 10 squared. So 3.83 squared is 14.67 plus b squared equals 10 squared, which is 100. Okay, I'm going to go ahead and subtract 14.67 from both sides. So b squared is actually equal to 100 minus 14.67, which is 85.33. Then I have to square root both sides. So when I square root 85.33, I get b being equal to 9.24. And so that would be my half of my base, right? So 9.24. Okay? So let's scroll back up so we can kind of see what's going on up here. So 9.24 is going to be my half of my base, right? And so if I scroll all the way up, half of base is what part of this formula needs. And so I really just need to take this 9.24 and plug it in where I see half base. So what I can do is I can now make it like this. It'd be minus 1/2 times the base, which was what? Well, half the base was 9.24, so we don't need that 1/2 now, right? Because I know what it is. So it's 9.24 times the height, which is 3.83. Okay, so 9.24 times 3.83 equals 35.39. And so now I'm just going to take these two numbers and I'm going to subtract them. All right, so let's do that. 37.5. Now I need to put pi in my calculator. Minus 35.39 equals 82. So this is approximately, so this area is going to be 82.42 units because we don't have a unit there squared because it's an area. All right, so let's go over that just one more time. So the area of a sector minus the area of the triangle will give you the area of the segment. The sector formula is the easiest part because you just plug it in. The triangle you have to actually pull out, look at it as an isosceles triangle. Okay? And when you do so, you can notice that you can split it down the middle to find the height and the base using trig. We went through and we used the Pythagorean theorem to find half of my base, right? So this would only be half of it. Now I could find the whole thing by multiplying 9.24 times 2, but it's kind of redundant because you're going to end up having to take half of it anyway up here, right? And so when I use this formula, which is half the base times the height for the area of a triangle, I just already know what half the base is. So there's no use of doing that double and then dividing it by 2 again. It's not going to make any sense. So 9.24 times 3.83, which we found from trig, equals that 35.39. We walked through and found all of this using the formula. We subtract this. The most common mistake is that you'll forget this pi and you'll get a negative number. This still would have been positive, but you need to actually keep that pi in your answer there. So 37.5 times pi minus 35.39. Okay, so this makes our total area of our segment 82.42.